A very good afternoon to all our participants of this course. Coming to the third lecture of this particular course, today we have Dr. Chandra Prakash sir with us. He is an eminent space scientist and has made significant contribution in the field of satellite communication technology development. He has a very vast experience of more than 20 years in GNSS and SATCOM technologies. Presently, he is heading the Satellite Communication Technology Division at Space Application Center, Ahmedabad. Today, we are very fortunate to have him as our guest speaker. He will be enriching us with his knowledge and experience in GNSS, specifically for the disaster management application. I hope the lecture will be very beneficial to all of you over here, and you will gain some new knowledge in this area. Over to you, sir, for your session.
Yeah, thank you very much. At the outset, let me thank IIRS team for giving me this opportunity, and let me welcome you all to this session. Already the introduction has been given, so I'll directly jump on to the topic. And I would encourage all of you to ask as many questions as possible. If important during the lecture, if you want towards the end of the lecture. But in the next 1 hour, I'll try to give you first the glimpses of this satellite based communication and navigation systems, which can primarily be used to the disaster management system. Needless to say that the space as such has been very useful tool for any country, any nation. And any nation like India, definitely like a space is something which is essential to do a effective disaster management. So what I'll do is I'll probably try to put my lecture in a form that I'll try to introduce you the importance of disaster management. What are the space-based tool which we use? And then focus will be on communication and navigation systems which are being put to use for disaster management. So India is vulnerable to different kind of disasters, be it cyclone, earthquake and all. This is an old statistics which says that it's a geographically vast country, even covering a lot of hilly regions, terrains, and face flood, cyclone and different kind of earthquakes. If you see the oldest data, which is like 2013 published data, 9 years before, the disaster used to have a GDP loss of more than 2%, which was enormous. Now, even like now, we are trying to minimize these losses. Any country would like to do that. So the disaster management becomes essential for any country. And now, if you see, there are 3 parts of disaster management. One is we call it preparedness, and then it is a pre-disaster phase and post-disaster phase. If you can divide them in 2 parts. So earlier, basically you prepare, then if the disaster happens, then you provide the relief and rehabilitation. Now the shift actually is happening with the invent of new techniques coming up, where you are able to predict an impending disaster well in time. So more focus is now on prediction of disaster and preparedness, rather than relief and rehabilitation used to be our major foray. But now we are trying to do a preparedness is better than prevention is better than cure. So prevention is early predicting the impending disaster and giving forewarning to the people and taking the necessary measures. So if you see this disaster management structure of the country, this can be divided into if you put a programmatic view, this is how the disaster management works in our country. We have certain aerospace and ground segments which basically provides you the scientific data, which provides you all today you talk about a space you get a met and ocean observation system, then emergency communication system, then the navigation systems. These space-based tools are providing you the knowledge about the real-time scenario. Even our high imaging satellites, they give you weather mapping is being done. Now these informations comes to this knowledge institute or institutional interface, like if you see on the left hand side, cyclone warning system, Central Water Commission, Indian Meteorological Department, Geographical Survey of India, Ministry of Earth Sciences, all these knowledge institutions actually they utilize this data, and they develop a different kind of, based on their respective field of expertise, they build different kind of forecast model, and they verify that forecast model with the in situ observations, which is again a satellite based systems where we collect the data. And once they are very sure about that their disaster is going to come, they pass on that information to a decision support center, where the basically administrator, either Ministry of Home Affairs, National Disaster Management Authority, Ministry of Civil Aviation, PMO, and all other state agencies, they are party to it. And when they find that yes, the information which has been derived by these knowledge institutions are credible, they try to disseminate that disaster warning to the masses, and they take other administrative action to take care of the disaster. And that's how this whole system works. So if you talk about that, how space is going to help, so space has got different tools: meta and oceanic graphic observation tool, communication tool, navigation tool, imaging tool. All this, if you see in totality, so basically a space is essential. It provides a convergent solution for disaster management by means of providing satellite based communication, met imaging, and remote sensing data. Now quickly I'll give you a glimpse, like the role of a space technology. You can put it primarily earth observation is one of the region where, like you if you see on the right hand side, there are so many earth observation satellites which today the country India has, which actually provides you all the essential data, be it a solar wind vector, be it oceanographic wind direction, velocity, all these parameters which are essential for our scientists to utilize their model and to predict a warning. So what are the warnings we predict? I'll come to that part. So they use this tool, earth observation satellite, to get that in situ data, in real time data, to do the prediction part of it. Once your predicted information and decision support system has approved, you need to disseminate the data in near real time. The challenge is how fast and how quickly we are able to disseminate this data to every part of the country. India being geographically vast, the population is very scarce in hilly region. There, getting the terrestrial connectivity is tough. So satellite based systems comes very handy there. So communication is essential for that. Even if the disaster has struck, then in that case also the first responders who are going to field to provide the initial relief, they also need to carry different kind of satcom gadgets like satellite phone, position reporting terminals, and all that. There also satcom comes into picture. Once they enter into a particular area where they have to reach and where they have to go, so navigation has formed now integral part of our day-to-day life. So India also now has its own satellite based navigation system which actually does that job. So if you see a space technology, earth observation, satellite communication, satellite navigation, they all form part of disaster management. Just to give you a glimpse that how we have progressed. Earlier, when the disaster like cyclone is warning is a very I would say a phenomena which is now we are able to predict with more certainty. And in the past 10 years before, when the cyclone used to happen, we used to have a loss of life of the order of 10,000 or so. Now, if you see in the recent past, whatever the cyclones are there, we are able to predict them even more than 72 hours in advance. We are able to track the cyclone movement. We are able to predict their landfall in time and able to save a lot of life. This has all been well demonstrated now. Similarly, if you see, we are now able to do something called nowcasting, the heavy rainfall prediction, monsoon predictions. All these predictions nowadays are based on a space-based observation, and we are now gradually with time, with more in situ data coming up, we are able to do much and our prediction models are gradually becoming more and more powerful. the beauty is that over a period of time we have achieved a probability of detection. If you see right bottom corner, the probability of detection of these cyclone systems has become 100%. Means all the cyclones we are able to predict with a false alarm rate of 3.8%, which is also now getting less, and success rate of 96.5%. The mean prediction time is 78 hours. So we are able to predict in 78 hours before. Now this information is available to us. How fast we can disseminate is the challenge. So in case of cyclone, we get 78 hours. But there are situations, if you talk about the nowcasting where the cloud bursts and things are being predicted, we hardly get 3 to 4 hours to disseminate. Heavy rainfall predictions, they are some sort of like, no, the prediction time actually decreases significantly. So first of all, before I get into the dissemination part, let me say that how this predictions happens. So ISRO per se, or for India, we have got a network of automatic weather station, AWS stations. So there are 1100 weather stations spread across country. This is being established by Department of Space. There are equal number is being established by Indian Meteorological Department as well. And if you see that all these satellite terminals are having lot of sensors which get the data, collect the data like temperature, humidity, rain rate, wind speed, wind direction, all this information put together, and every hour, every half an hour, in fact, it is now being transmitted to a central station, and that information is shared among the knowledge institution, and we are able to do the prediction of the impending disaster. Now, you talk about flood, earthquake, cyclone, landslide, forest fire, drought, all these are now being predicted. These informations are being predicted. If you talk about other applications, we have a real-time monitoring of weather events like cyclone genesis to cyclone landfall, met observation, heat wave. If you talk about everything is being predicted now and being available. Only thing is, the prediction time varies from one place to other, and this is like being supported by so many, like one automatic weather station. Similarly, for tsunami early warning prediction, if you look at this slide which talks about tsunami early warning prediction systems, just to give it an idea why SATCOM and SATNAV is essential, is now what you need to do if you want to predict a tsunami. What is essential is the bottom pressure of the ocean. Now there is no way I can communicate the bottom pressure of the sea. How it is being done today? There is a bottom pressure recorder which sits at the bottom of the sea. If you see this diagram, they work on a acoustic modem. They send this bottom sea pressure, they record, they send it using a acoustic modem to a data buoy which is connected to a transducer, and that information comes to a satellite transmitter which is in blue circle if you see here. Through insert, they send it to our INQUIS, which is the Ministry of Earth Sciences Department, where all this bottom pressure together with something called acoustic tide gauge. So there are tide height. What is the tide height? So tide height together with the bottom pressure and the AWS data is being utilized to do the prediction of tsunami. And I must say that this is one slide which I have put it here to just to show you all of you that see, we are now able to do the prediction, but the time which is available from the time we have predicted to the event to happen varies from anywhere from 6 hours to 6 days. So cyclone prediction we are able to do in 6 days in advance or 7 days in advance typically. Then in that case we have that time to send the rescue and to plan for the contingency. However, when it comes to us in hand, so we need to have a communication setup which is efficient enough, that which takes this information about this impending disaster to the community in less than 6 hours, preferably in near real time. So we need a real time all weather ubiquitous communication system, which is basically that is where the SATCOM becomes an integral part of it. So satellite communication and technology, how they are put in satellite communication and navigation technology, how we put in use for disaster management. So disaster we have divided in three parts for effective disaster management, and the definition of the SATCOM and SATNAV system, satellite navigation system, actually depends on this kind of definition. One is pre-disaster, where we say that predictions. So all kind of data collection, be it talking about the satellite based automatic weather stations, be it tsunami early warning network. So there it is primarily focused on collecting the in situ data real time. So in India, we have got 1200 stations, which gives me in situ data every half an hour. So we know that how the things are changing, how the meteorological space is changing. So that information so that is the pre-disaster phase. During disaster, what happened? Disaster has struck, flood has come. Now flood has come, what to do with that flood? How this we can put in use? So we need to send some first response. Badrinath was in flood. Uttarakhand flood, you talk about 2013 Uttarakhand flood. What happened? Now somebody has to go there and assess the situation and provide the relief. Now the first responders, they go through like other means, small vehicle. They cannot carry a big VSAT of 1.2 meter kind of system. So they need some kind of portable or handheld devices like satellite phone, a small reporting terminal, a small data terminal. So that is where we build a mobile satellite service network where the user is mobile. So we build that kind of terminals, which are primarily a very miniaturized in size, a small battery operated devices which can be carried by a person or the first responders in the time. At the same time, we also try to build some kind of ERVs. ERV stands for emergency response vehicles. So these are small cars which are fitted with a slightly bigger terminals, which can provide a video conferencing and IP data transfer from any location, any remote location. So that is the part that is the essential tool for satellite communication and navigation. And all these terminals like which we build are fitted with a navigation receiver. And so we accurately know where the first responder is, what services he is providing, where he need to go. So we do guide them in case of like on disaster sites using these terminals. They get the guidance. We have started building now the GIS based tools for them. Like we use day to day, we use maps in our mobile phones. Similar to that, we are trying to build into the mobile satellite service gadgets also, so that they are able to freely navigate. So we help them navigate in that disaster area. Then comes the post-disaster. Once the disaster is stuck, there is always a trapped population. In Badrinath, all the like people who have gone for pilgrimage, they were stuck. Now everybody wants to reach out to their family. They want to tell that, okay, I am alive, I am doing this. Or even our administrative agencies, they want to communicate to their bosses that what all they need to make it more effective to disaster management, what are their needs. So that time post-disaster, the focus is on rehabilitation and relief. That time the communication need grows. So there we try to set up a rapid deployable VSATs. We call it portable VSATs. We have a small aperture terminal, and there these terminals not only provide the higher data rate, I will later part I will show you that they are good enough now to generate a small like mobile network in the local vicinity. So this is what are the main challenging things in the satellite communication. This is a slide showing that how earlier we used to do cyclone warning. If you talk about 80s or 90s, we were having a 3.6 meter antenna, and today all the cyclone warning stations has turned out to be a 600-gram device. And to best analogy is the DTH systems which are there in each house. So IMD, if does a prediction of the warning, it can directly be fed to our one of the TV channels, and the DTH is modified in such a way that the moment that feed comes up, it automatically tunes to that particular channel, disseminates the disaster warning information, and then goes back to the parent channel. So without any user intervention, you can disseminate that information. More than 250 CWDS was installed in coastal areas and were maintained so far. Nowadays, we are gradually shifting to other methods of doing it. Maritime domain is one of the domain which is highly affected. Fishermen go for fishing into deep sea, and suddenly weather changes. They don't have any means to communicate whether they are stuck, what kind of the help they need. And so we have built a tool called a distress alert transmitter, which provides them few buttons using which they can send a distress message to Indian Coast Guard, which sends the rescue and gets them out in case of disaster. So they can send information about whether if they have a medical help, they have to press that a medical help is needed. If the boat is getting drowned, then they can press another button and the rescue will be sent. Every year we are able to save more than 20-30 lives every year on an average using these gadgets. So this is basically a UHF transmitter which works through our INSAT 3. Basically there are 4 satellites which supports that: INSAT 3D, 3DR, 3A was the older transponder, and GSAT 17. This supports, and we have installed a hub station at Maritime Rescue Coordination Center, MRCC, Chennai. This is basically a Indian Coast Guard office which actually takes care of the sending the relief and rehabilitation part of it. We also support something called COSPA SARSAT based system. SAR stands for search and rescue. So there is an international convention through which any person can carry, we call it EPIRB, emergency position indicating radio beacon. This is all being used in our emergency locator transmitter for avionic platform. So any aircraft carries that ELT, and PLB is being carried by persons. It is a personal locator beacon. So these beacons are being received through our satellites inside 3DR, and that information goes to INMCC, Indian National Center for this navigation and SAR operations. So they receive that information and they inform the respective authority to send the rescue. That's how we provide this rescue in case of maritime domain or aircraft, this thing. Okay. So now earlier we were working on GeoSAR and LeoSAR, where that the information was reaching slightly late. Now we have come up with a MEOSAR, and now we are, if you will see in this slide, we are able to sense, able to get the information on impending on a SAR beacon in less. This slide shows you about our maiden effort. India has got now its own navigation system. Earlier it was called IRNSS. This is a technical name which was given, Indian Regional Navigation Satellite System. But now it is fondly called NAVIC. Our Prime Minister has named it as NAVIC. NAVIC stands for Navigation by Indian Constellation. So we have developed our own ASICs, and now very soon it is it is coming in all the mobile phones. So they will be enabled by NAVIC receiver. Why earlier all of you have been using GPS, all of you have been using other navigation systems, GPS being the most popular one. The challenge is why we need to have our own system if GPS exists. The problem is GPS, the space segment is being being managed by Department of Defense of USA. In case of any exigency, any war-like situation and all, they can introduce certain errors which can result into our position error. So we don't know what position we are detecting is correct or wrong. So there is something called integrity testing, data integrity testing. System called Gagan, which actually does the integrity testing for these navigation systems for us. Parallelly, we have built our own navigation system so that we are very sure that which is exactly ours, not that somebody else. Now, this is another system which we have done. Now, NAVIC is a receiver system, okay, GNSS receiver system. Now, this receiver, it's a receive-only terminal and very low cost because this gets mass manufactured. So we have, since this system has been done all indigenous, we have a feature in that which is now getting internationally adopted also, wherein you can geocode and send a warning information. So if you want to give a disaster warning, you can do a geocoded that in this geo arc there is going to be a cyclone, in this geo arc there is a heavy weather prediction. So all that technology which we have built into this system and which is available now. As I already said, is Gagan is a system where we have our own the system, how this works. This is primarily for the valid data integrity checks. When I say data integrity checks, without getting much into detail, to know your position, you require 4 reference points. Okay, how these navigation systems work is they try to know their own position range with respect to 4 different fixed locations, and they do triangulation to calculate their position. Basically, if I have to put it in simple language, if you know your position from 2 fixed locations, you can draw 2 circles, and then you will find that these 2 circles intersect at a plane. So you can be anywhere in the plane. But if you know from 3 positions and take the 3 circles, there will be a unique point. There will be 2 points basically. So, and there is, if you have a 4th reference, you can derive time as well as also. So that's how this 4 satellite based systems is. You have to have 4 satellites in visibility to calculate your position. What Gagan does is, we have put at known locations, we put our receivers, GPS receivers, and we use known satellites to calculate their position. And since these are surveyed location, we know their position. But if we find that there is an error in position fix with respect to what is known to us, we try to eliminate the satellite which is causing that, or which is giving us the wrong FRMS data. And that's how we eliminate and divert to a separate channel. Okay. Now, as I said, you know that there is a cyclone which is going to come. During Oki cyclone, what happened is, we disseminated the information that there is a cyclone which is going to come back. So in Tamil Nadu, fishermen got that information, they started coming back. Unfortunately, they did not know how the cyclone is progressing, which way it is coming. And due to lack of that information, 6 of them, I think, if I remember correctly, 6 of them fall in line with that cyclone and lost their life. So it is not only essential to pass on that information that a disaster is coming, you also need to guide them that which direction they should come back, which route they should follow while coming back. So keeping that in mind, the UHF transmitter which I showed you, only distress alert transmitter, we now integrated with Navik messaging receiver, and we use the geo encrypted messaging feature to tell them that which route they have to follow. So that guidance also is nowadays being provided. This is also provided in another system. We call it, this is a MSS system, which actually has been being utilized for, okay, unfortunately this video is not playing, but this is if you see on the right hand side, it's a MSS terminal, which actually two-way messaging terminal, and it has got a built-in receiver, which transmitter, which is sending that position information every 15 minutes, and they send their position information. I'll touch upon this part once again. So this is a two-way system. You can do a small messaging also. So from control station, you can send a message and guide them how to come back. So coming back to the MSS SATCOM systems, for what are the other SATCOM systems which we done for first responders. So this is the mobile satellite system network which we did for the first responders. I'll just switch over to another few slides where I'll show you. Are you able to get my another slide? Is the second presentation visible? Can I get a feedback? Yeah. So this is where the GSAT-6, there is another MSS satellite. We have done this 4 kinds of terminal which are helpful for the first responders. This is if you see the 4 terminals here, they are basically one is, if you see the satellite mobile radio is nothing but a satellite phone, which is basically used for voice and a small data communication using this GSAT-6 satellite. So first responders, this is weighing around 600 grams only. There is a reporting terminal you see on the right hand side. This reporting terminal is primarily basically a position reporting terminal, and you can send a small message like kind of earlier days pager used to be there. So it is that kind of system. And This is a broadcast receiver, which is a receive only device, which actually we use to disseminate the large maps or any other ancillary information which needs to be disseminated. This is a USB powered very small device. And then in the middle you see that portable multimedia terminal. This is a small 3 kg battery operated device which can be utilized to do a video conferencing and IP data transfer from a remote location. So this is how these devices are tailored for disaster management activity. So you can do two-way voice communication and two-way IP data connectivity. And all these are weighing between 200 grams to 3 kgs. All are battery operated devices and very effective for disaster management. Using this satellite phone, you can, this satellite phones, basically we call it sat sleeve. So it sits behind your mobile phone, and then using an app, your mobile phone itself starts acting as a satellite phone. So you can do a, you can, using this device, you can call to any PSTN or any landline number also, you can call it PSTM as well. So the network can support more than 200 simultaneous calls. That is feasible. This is some of the technical features of this device which has been done. And now all these terminals and technology has been transferred to Indian industry. Now, what we have done is the responders can even wear, if you see here the right hand side, the watch. Nowadays you get an Android watch which has got health monitoring parameters. So these parameters talk to our sat sleeve through using a Bluetooth interface, and these informations are being transmitted to a central location, and there the person who is sitting there can know indirectly what is the health status of that particular person, like heartbeat, pulse, temperature. All this information you can remotely monitor for the data. So we call it that it is now IoT enabled also. So this, like, no, can satellite terminal also acts as a IoT gateway. So that kind of applications has also been promoted. This is a reporting terminal. As I already said, this keeps on reporting its position periodically, and it can also be utilized to send a small data. But this is a transmit only terminal, which is being utilized by the first responders. This is a broadcast receiver where you can send a audio message, video message, or data you can disseminate to the remotest area. Now, if you talk about this portable multimedia terminal, one of the very typical usage which I wanted to show you here is, in this is, these devices are comes with, like, no, you can connect these portable multimedia terminals with a Pico BTS. We call it a very small base trans receiver station. What's in the mobile terrestrial mobile network, what sits on the top of your houses, actually you can make it sit on the connected with this particular terminals in the remote areas, and then locally you can create a mobile network, and that will work. That will support up to 8 voice channels directly without using anything. So basically for trapped population, you can generate a small mobile network, and they will be able to call it and reach it here. You can do a secure video conferencing if you want. So these are the gadgets which has been developed and which has been demonstrated in field, and these are our initiative. And this is how the gateway, all these terminals, when send the information, they are received at one place. We call it hub. At that hub, all these services are basically combined at IP layer, so they can talk from each other, one to other. They can talk to each other. So all these services can unanimously be uniformly be utilized. So some of these operational MSS initiatives, as I was telling you, that this is some of the initiatives which ISRO has undertaken. So wherein, like, no, we are able to show you that this is for maritime. For maritime, we are able to communicate to users, like, no, we are able to show them that what we are doing it. Similarly, like, if you talk about these terminals, we are providing, like, now, as I was saying you, that two-way MSS terminal, this is primarily utilized for fishermen who are in distress. So this network is able to support around 2.5 lakhs of boats. So the idea is all these boats will be fitted with these terminals, and their data will be available on a central station to our rescue agencies and different state fisheries department, and they in turn will be able to send a message and receive a message from these fishermen who are in deep sea. We have all these terminals have been provided. If you see on the right hand side, a Bluetooth connectivity and a mobile app, And these are some of the technical features. If you go to the mobile app, this is the kind of app which we have given them. So using this app, they can send an emergency. If you see the second part, if they need a medical help, they need to repair the boat or some man overboard, whatever information they want to send, they can send. And similarly, the control station can send them a message, and they can do these kind of information sharing when even when they are in deep ocean. So like earlier, if you all of you must be reading in newspaper and all places, like no, okay, our fishermen are being caught by our neighbors. So nowadays we have given a facility called geofencing in these networks. So the moment you reach near to a international maritime boundary, you will be able to get an alert, and even our control stations can send a warning to them that you are crossing international boundary and please do not cross, so that the lives can be saved. So this all effort has gone into this. So these are some of the initiatives which we have taken. One of the very I would say very important initiatives is that now our all railway system, railway also comes under like in case of disaster, the movement of these freights and all becomes also challenging. So we have built a real-time train information systems based on our own SATCOM and SATNAV systems, which actually provides real-time train tracking information systems. So you get more accurately, you get the train positions, and you are able to do the management of this freight in case of disaster. Okay, so this is which I was discussing you. Now coming back to the last part of the this segment of this, where we said that ISRO has created a DOA, Department of Space has created a virtual private network for disaster management. What this does is, this is a VSAT based system which interconnects all the departments, all the knowledge institutions which are essentially required for disaster prediction and information dissemination, be it a cyclone warning system, Central Water Commission, Indian Meteorological Department, so or Ministry of Earth Sciences. So left side, if you see all the knowledge institutions centers, then the decision support center and the nodal agency for disaster management, together with a state emergency center, they all are connected in a single SATCOM network which has been designed for them. And on the right hand side, you see there are some emergency response vehicles. These vehicles can be taken to disaster site in case of impending disaster. So this is like 9 important institutions are connected with all 26 state emergency operation systems across the country using GSAT-12 satellite. And this is the operational network which is now being upgraded to cater to a higher network capacity. If you see all these systems, all the systems which are deployed in field, they have a telephone connectivity, they have a video conferencing capability, and they have got a data connectivity. So video, voice, and data all are being connected. These are some of our we call it synthetic aperture radar, DMSAR, disaster management SAR, disaster management synthetic aperture radar. These are basically mounted on an aircraft. Radars are mounted on this aircraft. So whenever like this is being done to do the flood assessment or any kind of disaster assessment in case of disaster. So this SAR also has been developed indigenously and being utilized for disaster management. Now the last segment, which I will take 15 minutes to summarize that. Even though these all things existed, what was our experience and how we are upgrading ourselves. So when Jammu and Kashmir and Uttarakhand, they had disaster recently, last 2 disasters. So when our team went, we felt that we have made a network, but we do not have trained manpower. They were all administrative staffs were sitting there, not so technically trained. So even though the systems were there in place, it took us very long time. The response time was too long. And some of the ERV, if you see on the right hand side, it's a real site picture. When we tried to take an emergency response vehicle to site, we got a flat tire. And the tire which was there inside, that also was flat. So even though means are there, if they are not maintained properly, and if they are like no, so there were many administrative and logistic challenges, lack of trained manpower. These were some of the things which were like no the bottleneck in making it more effective. Some of the things which were like this network, because of security reasons, because of lack of infrastructure, were not connected to internet, and now everybody everywhere wants internet. So that was another problem. And third problem was, if the disaster is in Uttarakhand, whatever the decision making has to happen in Uttarakhand. So yeah, so all the disaster management network today, the headquarters is in Delhi. So Delhi can do a decision making, but it is better if the decision making is passed on to the respective states. So the idea was, why can't they, the nodal state can be made a decision making agency. So we did that. And second challenge was, VSATs were available, but then when we went to the hilly terrain of Uttarakhand, we found that uh, you can establish a VSAT on the top of a hill, but the people who are trapped, the population is down the hill. Now everybody has to come to that VSAT, and then only they can make a call to their family. So which was making this very ineffective. So we felt that if some way we can increase the reach of that particular VSAT network locally, that would be. So we added a CDMA based Pico BTS, and we created a small CDMA network, mobile network there, to make it more effective. So all this we did. By that time, the Uttarakhand learnings were used to modify, upgrade the system. Jammu Kashmir actually fell into disaster, and then our team went there. But I just wanted to inform you that some of the learning which we could deploy, which we got from Uttarakhand, we took in place when we went to Jammu and Kashmir. And you see on the top left corner, with the Omar Abdullah, Raj Bhavan was actually made all Wi-Fi enabled using our VSAT network. VSAT was installed in Raj Bhavan, and then there was a Pico BTS, like what we call it is a CP, Wi-Fi CP was put in place. On the top right corner you see, and the whole area was given internet connectivity using our VSAT. So things were very effective there. But so these are some of the activities which we carried out there and tried to make it more effective. But our learning was that you cannot have a single layered network architecture to make disaster management more effective. SATCOM alone may not do the job, because sometimes the network capacity requirement is too huge for SATCOM to handle. So, and at the same time, some of these things also require, like our VSATs, though although we call them rapid deployable, they were very heavy weights. So we needed that to be made light. So we needed and at the same time, we also needed some administrative things we identified, like administrative preparedness, that you should have the regular mock drills so that people on the ground are well versed with the requirement. You need to give them e-governance training, that how to utilize that network, and some SOPs should be there to make quick decisions on the ground in case of disaster. So these are, technology is important, but these are equally important to make them more effective. So these were some of the things which we communicated to the management. And now, in order to improve our technical capacity, we have now upgrading the waveform. This is slightly technical, that now we are trying to make all these VSATs the same kind of VSAT. Sorry for this small interruption. All I was saying to do that we are still we are upgrading the technology, but at the same time, some of the philosophies, operating philosophies which we need to work upon, that now we need to kind of demarcate and delegate the responsibilities. So we say that now state emergency operation centers we have to establish. And then similarly, a district emergency operation system should also be established. So the network has got to be layered. At some places, wherever it is possible, it should have a terrestrial backbone, but in turn, there is a SATCOM backbone which is required. And this network has to be terrestrial, SATCOM and OFC, all should be put together. And there should be dedicated resources available for the disaster. It should not happen that once the disaster has come, then we are looking for that which country, which state can release the bandwidth for the usage of this. So we should have a design philosophy wherein all the bandwidth could be dedicated to the states which are into disaster. Not that the dedicated bandwidth has given for each states and all that. So these are some of the learnings and the network operating philosophies. I thought I will put it to you also. You can utilize it selectively wherever it is required. So training of manpower and maintaining a central resource pool is essential. Now, if you see our state, like no country has progressed so well, we have a NDRF team there, which is actually well trained, and whenever this happens, they send a rescue team to different states. So they are maintaining a centralized pool of resource pool, which is basically utilized by. Similarly, that is equally important that we should have a centralized pool of resources to handle this, like no technology element of it. So that is also gradually coming up. Then interconnectivity among networks. At the end moment, we should not look for that how we can get connected. All these knowledge institutions should directly be connected to the network and contributing to it. So this is how we have proposed the new network. This is the existing network which is today for disaster management, which has got a 4.5 meter hub, which is with MHA at this, I think, Samanvaya Sadan in Delhi. It is established today. We are proposing now to upgrade it to 11 meter, so that we are able to support better throughput with a new waveform. We are saying that we should have a state capital district emergency, like no rescue vehicles. All these rescue vehicles should be there, and a state emergency operations center should be established. We are saying that all the states and this knowledge institution should also be connected through a terrestrial network to reduce the burden on the SATCOM element. We are saying that all these hubs should directly, all the time, they should be connected to the GSM, PSTN as well as internet gateways, so that in case of disaster that could be utilized effectively. We are saying that similarly the user side, at the remote side also, all the GSM and Pico BTS and this FM transmitters. FM broadcast is one of the very popular way we can disseminate certain information in disaster area, and very helpful also. So we have proposed that. And then we are saying that the mobile satellite service network for first responder, that should also be a part of, integral part of this disaster management network. If we do this, this is how the disaster management full-fledged network will look like, with a National Emergency Operations Center, State Emergency Operations Center, and probably a district emergency operations centers, and multi-layered network architecture. This will provide us a better disaster management. These are some of the things which we have proposed, that in case, like no, you can even do a WiMAX extension of these devices. So if suppose this fixed satellite terminal is mounted on a hilltop 5 to 10 kilometers down the line, using a small 0.6 meter kind of antenna, you can provide a connectivity in a last mile connectivity. So that kind of network has been proposed today. And all these services. Now, one of the major technical challenge was, all of you are a student and other place working professionals, you must understand that all these terminals need to converge at some layer. WiMAX has got a different protocol, Wi-Fi has got a different protocol, and VSAT has got a different protocol, satellite 5 has got different protocol. So all these protocols has to merge somewhere. So the technological convergence can be achieved only if we bring them at IP layer, they can converge. And this is what the slide says, that all of them, which are going to form part of the integral part of this network, they have to converge at IP layer, and that technical effort has to get into that. And this is what we are trying to, the last slide probably of my presentation, where I am trying to say that you should have a common national portal which is accessible, where all the information, be it related to satellite imagery, weather information, be it related to tsunami warning, be it related to weather monitoring, any or every information pertaining to the disaster management should be available using a single portal in a hierarchical fashion. You can always disseminate that information in a hierarchical fashion with administrative control in a secured way, but it should be available at one location, so that people don't have to rush here and there in case of disaster, and the response time could be greatly improved. This is what we say, that all the early warning applications, decision support, GIS, disaster management, they all should come in a single architecture. There is a saying that if you fail to prepare, be prepared to fail. So it is always better that we prepare for the worst and hope for the best. So the best preparation for tomorrow is doing our best today. So we all are trying to put our efforts together, so that we are able to minimize the loss of life in case of disaster. And for that, the SATCOM and SATNAV, this has been two essential elements. Now, today India has its own navigation satellite system with 7 satellites, which is supporting the satellite-based positioning. Unfortunately, 3 of them has gone down because of some onboard issues. Very soon, we are going to replenish them, and then you will have our own indigenous navigation system together with the SATCOM space element, which will help you to make the disaster management very effective in the country. And that's all I wanted to convey. The floor is open for question answer if they have any. Thank you very much for your time.